We could put laptops away, that'd be great. X squared plus 7 is equal to a negative 47. How do I solve an equation that looks like this? What format do I use? Okay, there's still laptops out. They should be away. Not in y-intercept form. FOIL is not a way of solving.
I don't know what it's called. I just know the symbol.
Square roots. We can solve this by square roots because there is a squared term, but there is not a regular x term. If I want to solve via square roots, Taya, where would I start on this problem? How? 3x squared equals negative 54. I'm waiting to call on people. I was just giving people a chance to write. Got name cards. But yes, divide by 3. X squared equals negative 18. Fine, now what? Now I take the square root. Grady, when I square root, what can I not forget to also do?
Add the I.
Nope. Yes, but nope. It's not what I'm going for. Every time we square root, not just imaginaries, we always put plus and minus. Now, Grady is 100% right. We are going to have an I in this problem because we are square rooting a negative. And I could pull off that square root of negative 1. I'm left with the square root of 18. Now that square root of the negative 1 is going to become I. Carter, can I simplify the square root of 18?
Yes.
How? Math! I love it! There's a little bit more to it. We look for the biggest perfect square that divides out of it. Biggest perfect square that 18 divides by? 9. It's square root of 9 times square root of? 2. Which of those is the perfect square?
9.
Why do we have a laptop out? So, x equals, what goes first? Positive negative goes first. What goes next? 3, then the I, then the square root of 2. Is no real solution still an option?
Yeah.
If I ask you to solve, no, it is no longer an option. Zero equals negative 2, parenthesis, x minus 3, quantity squared, minus 16. Luke, where do I start?
Add
16?
Yeah.
Wait. To the correct place, please. 16 equals negative 2, parenthesis, x minus 3, quantity squared. Matthew, now what?
Divide both sides by -2.
You got it. -8 equals x minus 3 squared. Yes, we now square root both sides, and when we square root both sides, we do not want to forget what? Positive and negative goes on the square root of the number. So I've got a positive and negative, and I've got a square root of -8 equals x minus 3 is left over there. Can't call someone who's not here. Doesn't work that way. Brett, what do you think I should do next? There's a couple different options. I'll come back to you on a different one. Bailey, what are you thinking?
Split up the equations into the positive number. First take the largest perfect square that equals something.
I would simplify the square root first. You could split into the two equations at this point, but simplifying that first is going to make it easier. Okay, so positive, negative. I've got a square root of a -1. I'm going to pull that off first. What's the biggest perfect square that divides out of 8? 4. 4 times what? Now, I have not taken any square roots yet, which means all of those are still in square roots. Once you take the square root, get rid of that symbol, but before you take it, it still needs to be there. Which one can I take the square root of nicely?
4.
The 4. Bella, what order do I write things in over here?
Plus or minus 2i and then the square root of 2.
Good. Square root of -1 became our I, square root of 4 became the 2, and the square root of 2 didn't change. Now is when I would generally split into my two equations, if I split it at all. And we'll talk about that here in a second. Don't mind me. When I split it into two equations, do I still put plus or minus? No. I put one as positive, one as negative. That's the point of splitting. X is not alone. Want to get it alone. Connor, how do I get X alone? I don't know what you said. Got it. Perfectly fair. Add 3 to both sides. I could do that in both equations. Are there like terms? No. Which means it just ends up having x is equal to, you can write it as 2i square root of 2 plus 3, but more commonly, they put the whole number first, and then they add the imaginary part. Or on this one, whole number first, 3, and since the imaginary part's negative, it's minus. In the situation where they are not like terms, did I have to split it into two equations? No. From right here, I could have said I'm going to add 3, I'm going to add 3, and I would get x is equal to 3 plus or minus 2i square root of 2. Do I care if you split it or don't split it? No. Choose whichever works best for you. So, today you're going to see a little bit of solving, Generally speaking, it solves in the same way as what we've been doing. We just have to square root and get some imaginaries now. You're also going to see some more simplify problems today. Now, yesterday we saw simplify problems, and we saw that for the most part, when you're simplifying with I, you're just treating I like it's a variable, even though it's not. There is a tiny bit of an exception to that rule, though. If you saw a problem like this, what do you think you should do?
Distribute the 5i into everything else.
Yes, and we do still do that even if it's imaginary. What is 5i times 4? 20i. And what is 5i times 2i? Positive 10i squared. Here's where the exception to the rule comes into play.
Isn't I squared negative 1?
No, it would just be negative 1. Because you're squaring a square root.
Here is where we differ in treating I like it's a variable. Dang. I can never be left with an exponent. Because if I has an exponent on it, it will always simplify. Because as people have pointed out,
I squared is equal to negative 1.
can you let me finish, please?
Okay.
As people have pointed out, I is a square root. I is by definition the square root of negative 1. Which means when I square it, my square root of negative 1 squared has the square and the square root cancel, and it becomes negative 1. You're not wrong. Not everyone was there yet. And I could simplify I to any power if I really wanted. And the way that I would simplify it to higher powers, like I to the third power, is I would think about the fact that I to the third power is just I squared times I to the first power. And if I squared is negative 1 and I to the first power is just I, then all of a sudden I to the third power is a negative I. And I could keep going. I to the fourth power, I'm going to just break up into I squared times I squared, would be like a negative 1 times a negative 1. And essentially, this pattern continues on forever. I to the fifth power can be written as I to the fourth times I, and since I to the fourth is 1, 1 times I just becomes I. And the pattern continues. I is I squared is negative 1, I cubed is negative I to the fourth is 1. To the fifth power is I, to the sixth power is negative 1, to the seventh power is negative I, to the eighth power is 1. To the ninth power is I, to the 10th power is negative 1, to the 11th power is negative I, to the 12th power is 1. Are you getting the picture here?
Yes.
Yeah.
I to any power can be simplified. So, distributing this is accurate, but it's not done. If you see I to a power, it needs to be simplified. I replace my I squared with the negative 1 that it's equal to, and I go from there. What's between the 10 and the negative 1? Multiplication. What is 10 times negative 1? So this is 20i minus 10. Or more commonly, you'll see it written as negative 10 plus 20i, because generally, in a complex number, they like to have the real part first. If you don't switch it around, I don't know what you're talking about. If you forget to switch it around, it's not the end of the world. I'm not looking that you switch it around. I'm just telling you they generally will. Am I going to give you I to obnoxious powers? No.
No.
Could I?
No.
Maybe.
Like what?
I could. It's tempting. I'm not going to. It's tempting specifically for some of you.
I probably have been about that.
You might be one of the people it's tempting for. I will give you problems like this, though. How do I simplify that? I distribute. Big distribution this time. 2 times 4. 2 times negative 6i.
12i. Negative 12i.
Negative 12i. 3i times 4. Positive 12i. 3 times a negative 6. I.
18i.
Negative 18
I squared.
I squared. Traditionally, at this point, we just combine like terms. But there's one further thing you have to do because it is imaginary. I to a power cannot stay. Those cancel out when I combine like terms. I get 8 minus 18, and I squared becomes negative 1. Well, that's like 8 plus 18, which is 26. Multiplying imaginary numbers will not always stay imaginary. Sometimes it can turn into real. Make it nice and big and in your face. Because I'm going through my name cards again. Beckham, where would you start on a problem like this? Just into the 4 plus I? Beautiful. Is this how I write it? When you distribute, generally parentheses go away. That rule is different if there's more than 2 things being multiplied. Layla, what would you have me do next? We're not adding or subtracting. We can't combine. We're multiplying.
Then we would distribute the 12 to the 5 and the 2i and the 3i to the 5.
Exactly, I multiply all those out. Brett, what is 12 times negative 5?
60.
Negative, but yes. Y'all know you can have calculators, right? Evelyn, what about the 12 times negative 2i?
Negative 24i.
Perfect. Mitchell, what about the 3i times negative 5?
Negative 8
Molly, what about the 3i times the negative 2i?
Negative
Squared. Oh, okay. Isaiah, what should we do now? Which ones are the like terms? Perfect. Negative 60 minus 39i minus 6i squared. Peyton, am I done? What have I not done? I squareds become negative ones. Have you noticed that I haven't really come across I to bigger powers? It's almost like this is the main one that pops up. Or pretty much the only one that pops up. Make sure that as you are doing this, you are being careful with your positives and negatives as you are combining like terms. So it's a little bit different than what we did yesterday, but for the most part, it's a lot similar to what we were already doing. At least this part. There's one more thing we're talking about today. It's what's known as a complex conjugate. Complex conjugate switches the sign that's between the real and imaginary parts of a complex number. To its opposite. That's really its definition. Here's what it means. If I have a complex number in the form of a plus bi, its complex conjugate would be a minus bi. Or if the original was a minus bi, the conjugate would be a plus bi. Conjugates are a really important thing as we move into certain topics in math. So recognizing complex conjugates is going to help us with some of that. So you're going to see some questions that say multiply by the complex conjugate, or find the product of this and its complex conjugate. And it'll give you a complex number. If I give you 2 minus 3i, sir, what would you say is the complex conjugate?
2 plus 3i.
Exactly. And I want to find their product. In other words, I want to multiply them together. So I'm doing this. And guess what? I'm going to FOIL it out. 2 times 2, 4. 2 times 3i, 6i. Negative 3i times 2, negative 6i. Negative 3i times positive 3i is negative 9i squared. Caleb, what would you have me do next?
That's a good question.
It is, and it's one you know the answer to.
Is it?
Yes.
Combine like terms.
Combine like terms. You did not need help with that.
No, I did.
I didn't say you didn't get help with it. I said you didn't need help with it. Taylor, what would you have me do next? I have no clue what you just said.
Go up to like -1.
The I squared turns to a -1.
Yeah.
That becomes 4 plus 9, which is 13. In fact, the product of complex conjugates should always be a real number. The one thing that I just want to deal with, we're not going to necessarily finish this entire problem. I'll tell you what the answer is, in case you are someone who wants to try it out on your own. But ones like this tend to cause some issues. Caleb,
What's up?
shave. Other Caleb. There's 2 Calebs in this class.
I didn't know that.
Yes, there are. You spell the names differently, but there are 2. Caleb? He's back there. What's the conjugate of this?
-4 and -5i.
Yes. Far too often, when I ask people for the conjugate of one like this, they look at that negative and they say, okay, it's +4 minus 5i. Now, the conjugate only changes the middle. So, please be careful with that. Now, as I said, I'm not going to do this entire thing. If you are one who wants to, oops, that's minus. Try this out on your own. In the end, you should end up with 41. You lost a negative along the way. Okay, that's it for notes today. We're on page 105 again. No, we were on 95 on Tuesday.
That was 2 days ago.
29. 30 through 46 is the evens.
And then 56
And 56 through 64 is also the evens.